Okay, so that's on Tuesday we're talking about the graphing, or I give you a graphing problems for y equal to 2 plus 1/4 secant of 1/2 x minus pi. So first I'm going to use the transformation method to graph it. So if I'm using transformation, or I think our textbook talking about translations method. So from the equation we know the graph is going to be shifted up by 2 units. The amplitude is going to be 1/4. We need to change in the 1/2 x minus pi. So first the period is going to be 2 pi over 1/2, which is multiplied by its reciprocal is 4 pi. And then the shifting, so we have to rewrite 1/2 x minus pi into 1/2 multiplied by x minus 2 pi. So the shifting is shifting to the right by 2 pi. Okay, so that means our starting point is going to be 2 pi, and then go all the way to 6 pi. Okay, so I do have it here, so I'm going to label it 2 pi, so this is pi, 4 pi, and then 6 pi. So first, I'm going to graph the parent graph, which is y equals 1/4 cosine of 1/2 x minus 2 pi plus 2. According to the method, shift up 2 units, so that's why my dotted line is start at 2. The amplitude is going to be 1/4, so I have my landmarks here. This is about a quarter above the 2 line, and then a quarter below the 2 line. The period is going to be 4 pi, start from here all the way end up to here. And then it's a cosine graph. So cosine graph, just having some locations. So this one is start from here because it's a cosine graph. The low will be here. And then it's going to be approximately here. Actually, I have the ruler. I can measure it. It's approximately. Okay. So this is the dot. The second one, because it's going to cross the 0. Third one, fourth one, and then back up. So the cosine graph, it looks like this shape. But we're doing the secant graph. So here are my asymptotes. I need a little bit longer. So I'm going to reflecting the graph. So the green one, that's one period of the secant function, the corresponding secant function. If you want to continue, then normally I'm not going to ask you. I'm okay with just one, or I prefer one period, but just in case you want to continue, oops, then I do not have the 7th pi, so it's going to go that way with the asymptotes. Okay, so that is the graph. It's 1/4, so it's really tiny. So this is approximately 1.75 or 7/4, and here is 9/4 or 2.25, depending on the form you like. So I'm just doing approximately halfway between the 1 and 2, and then halfway between the new mark and then the 2. So that is the 1/4 distance. Okay, so this is this is the way I use it, using translation method. If you do not use transformation method, you prefer to actually finding the 5 point, or you do not want to do this changing the 1/2 x minus pi into something else, also figure out the period, then you can using the second method. So you still have 1/2 x minus pi. Regardless, our function is a secant, cosecant, sine, cosine, even in the future tangent and cotangent. When we set up our inequality, we always whatever apply to the trig function. So for this case is 1/2 x minus pi. So 1/2 x minus pi. Normally the period is going to be started from 0 and to 2 pi. So that is how we set our inequality. Now we're just going to solving this equation, adding pi on both sides, multiply by 2 on both sides. So that tells us our period is from 2 pi to 6 pi. And then the 5 key points are 2 pi, 6 pi, number between 2 pi and 6 pi are 4 pi, or is 4 pi. Between 2 pi and 4 pi is 3 pi. Between 4 pi and 6 pi, that's 5 pi. So those are the 5 points we have here. And then you're just going to graph, we still follow the same thing, graph the cosine graph on those 5 positions. After that, followed by switching it, graphing the secant graph. So again, this is really hard to see it because of the 1/4, and then everything else is really big. Also, if you're checking the answer keys back onto the back of your book, the answer keys in the book do not have the same pictures as we do. The answer key, I believe, only have I try not to touch it. So the answer key in the back only have those two pieces. Personally, I think it's really hard to just directly graphing those two, like directly getting the answer. I still prefer graphing the sine or cosine graph as the support graph or the support step, and then graphing the corresponding secant or cosecant graph. And because that is how I graph it, I have the support. For this case, it's a cosine graph. So my secant graph looks a little bit weird because it's not two parabola. It's actually one whole parabola with two half parabolas. But they are all correct. It's just depending on which piece we're looking for. So as long as you're only graphing one period, which is two, if we're adding up everything, two whole parabolas, one is facing up, one is facing down, then it's okay.